If I go back to the pre-analysis framework, what we are doing is we're going to move from talking about the mathematical model to talking about the numerical solution procedure. And in particular, how do we solve this mathematical model numerically using the finite volume method? The first step is to divide the domain into multiple control volumes or cells. So you take the domain that you have, the solution domain, and you divide it into little chunks, and these are called cells, or each one of these is called a cell in the finite volume method. In the finite element method, these are called elements. So cells versus elements, it's essentially referring to the same entity. It's a different terminology. We will use each of these as a control volume, as we will see in just a little bit. And here we have divided the domain into 12 cells. The next thing we do is we reduce the problem to determining velocity and pressure values at cell centers. So I've marked out the cell centers here. I have 12 cells, so I have 12 cell centers. And at each cell center, I need to determine velocity, which I have two components, and pressure. So I have 3 unknowns at each cell center, and I have 12 cells, so I have a total of 36 unknowns. So I've reduced the problem from determining 3 unknown functions to 36 values, and that's a big reduction. And so, so we've gone from determining unknown functions to selected variables at selected points. And this process is called discretization, where you're reducing the problem to determining just a finite set of values. Cell center values are approximations of the cell average values. And this particular flavor of the finite volume method is called the cell-centered finite volume method. There are other flavors of the finite volume method, particularly the so-called node-centered or the vertex-centered finite volume, where you determine the unknowns directly at the corners of the vertices. That methodology is a variation on the cell-centered methodology. We will focus on the cell-centered methodology here, and that's a methodology implemented in ANSYS Fluent. So then the crux of the problem is, how do we determine the unknown velocities and pressure at the cell centers? Let's talk about that next.